This is an experimental 20-foot shipping container filled with renewable energy technology. It's called the Power Hub, and it's been designed to push the boundaries of sustainable energy solutions using technology which is already available.
Well, we desperately hope that people see that readily available off-the-shelf technology, which is you can purchase the stuff that's in this container, can be combined to something that fits the needs of, in this case, the compound, but it can also work for a company. It can work in a office building, it can work in a yard. It doesn't really matter. You can make it fit towards your purpose, and if you put enough effort into it, it is possible to make a very big impact.
So what we're also trying to show with this Power Hub is that it's very much possible to be self-sustainable. It is, of course, still difficult. It takes a lot of work, but the technology is there and it's going to get better over time, and we should all embrace it to get rid of fossil fuels in our lives.
I'm Peter Dibbits. I'm project manager for Cruise Marine Projects.
I'm Baldwin van Groos. I'm involved here with the software for the Power Hub that we have behind me.
With sunlight as the only source of energy, it's able to provide everything you might expect from a grid connection. Electricity, water heating, building cooling, and even fresh water.
Well, the primary energy source of the Power Hub is the sun, which is basically the energy source for every energy we have on Earth. Fossil fuel is just the late sunlight. And we're using it directly in terms of electricity. We're using PV panels that you can find on quite a lot of roofs nowadays, storing that into a battery so we can use it if the sun is on the other side of the Earth. And we are also harvesting heat from the sun using heat pipes. And what we are trying to achieve is to change that mindset of having heat as a waste product and instead seeing it as something that can be useful. It can be used for supplementing traditional air conditioning through heat-fired chillers.
Both energy sources can be used to supply and convert. So you can use electricity to make cold for an AC system. You can use the heat from the sun to heat up your hot water for your showers or your tap water, but you can also use that heat to cool things. That's why we introduced a very innovative system in this compound that makes cold from heat. So what we trying to achieve is to get the most out of the energy that we get from the sun in all its shapes and forms.
These heat harvesting tubes on the Power Hub's roof are the same vacuum tube collectors found on domestic rooftop solar water heaters, and they can heat water to 100 degrees Celsius even when it's cool outside.
Well, capturing heat is pretty easy. I mean, we do it all day. But the difficulty is mostly in getting heat at a high temperature, because heat, of course, likes to sneak away every now and then through evaporation or through the wind. So we are harvesting heat through heat pipes. Heat pipes are a glass tube that's been vacuum cooled, and they have a little bit of liquid, usually just water inside of them. And because it's a vacuum, that insulates itself pretty well, and all the heat that goes through the sunlight into the water stays in there. The benefit of hot water is basically it comes down to entropy. You don't want energy, but you want useful energy. There's basically nothing you can do with water that's 30 degrees. But if you have water that's 80, 70, 90 degrees, then you can use that, for example, to boil water if you have a pressure chamber.
Once the electrical and heat energy have been harvested from the sun, it needs to be stored in batteries for when it's needed.
The dilemma that you always run into with solar energy is that you produce a lot of energy in a very brief period of time, and usually it's not even a time that you need your energy the most, especially if you look at heating or lighting. So what we are trying to achieve is to prolong the use of the energy that we can catch during that brief period that it's at its highest, and prolong that use during the day.
Yeah, so one of the downsides of heat is that it being like the F tier of energy, it is quite difficult to store. For electricity, we have capacitors, we have lithium-ion batteries, we have lead batteries. For heat, there's basically two ways of storing it, specifically or latently. Specifically is the process of heating things up, which we are probably all familiar with. Latently means that you have a material that goes through a phase transition. Usually that means that it goes from solid to being liquid. What we have in our Power Hub is we have a huge vat in which we'll throw stainless steel balls, and those stainless steel balls have been filled with salt that's been modified to transition from solid to liquid at 78 degrees Celsius. And that means that as soon as we hit that phase transition point at 78, that means all the heat that goes into the phase change vat, instead of heating everything up, it just melts the material. And it keeps storing that energy until all the salt has been liquefied, has melted. So it's very useful storage because we have that fixed temperature, but also in terms of energy capacity per weight and volume, it's far more efficient than using water would be. Water is quite efficient energy storage compared to other liquids, but still it doesn't compare to using a phase change material as we do. We have about 600 kilograms of salt in here. If we had used water, we would need 1.8 tons, so 1800 kilograms of water.
Now that the sun's energy has been harvested and stored in lithium-ion batteries and a tank of phase change material, it's time to use it. And air conditioning is one of the biggest consumers. So the Power Hub also contains a heat-fired chiller, which functions like an air conditioning unit, except it can be powered almost entirely with heat energy instead of electricity.
And that's what we're doing with the Yazaki over there, our heat-fired chiller. That's taking in water that's around 80 degrees. It's pushing that back out as water of, say, 60, 70 degrees. But it's also taking in water that's, say, 10 degrees Celsius and pushing water out that's 8 degrees Celsius. And 8 degrees Celsius is a beautiful temperature for air conditioning.
The final piece of the puzzle is water desalination. Whenever there is energy in excess, the Power Hub can take in seawater and turn it into clean water for domestic use.
So if we have additional power available to run a reverse osmosis water maker, which we also have in the Power Hub, you won't be using any water from the grid, and it's water that's already available because it's in the sea.
What we're also doing is capturing grey water, so that's water from the sink, and we're treating that so you can reuse that as technical water, so you can again flush a toilet, run a tap, and that's a far more energy efficient process because you don't need to run the dirty water through a lot of filters, but you can just take the water, dump out the particles, and then reuse that water again.
At the end of the day, all these systems allow the Power Hub to allocate energy to where it needs to be in real time, thereby eliminating waste and maximizing efficiency.
So if you're going to walk away from this, I hope you take with you the idea that energy isn't free. There's all sorts of work being done by your municipality, by your government to make that energy available for you, and that comes at a cost. And we want to make you aware of what it takes to supply energy, to supply electricity, to supply water. It's not something that just appears out of thin air.